Hello everyone, we are from Group 4 and in this video we will present our report on Innotech Manufacturing, a mid-sized engineering company that produces high-efficiency HVAC units for hospitals and green buildings. So Innotech Manufacturing is planning to expand its operations and invest in new capital equipment. Therefore, it is important to evaluate its current manufacturing operations and financial position before making the expansion decision. In this presentation, we will cover cost classification, costing techniques, budgeting, break-even and profit planning, capital investment evaluation, inventory and cost control, performance measurement, project cost management, and decision-making tools. And throughout this analysis, we aim to determine whether Innotech's expansion can remain profitable, efficient, and flexible in meeting the future market demands. Without further delay, we will begin with the first section.
Good day, everyone. I am Aiden, and I will be discussing the cost classification and cost behavior for the HVAC expansion project. Effective cost classification is essential for accurate budgeting, cost control, and decision making during production expansion. Costs can be classified based on their traceability to products and their behavior as production volume changes. First, steel casing is classified as a direct cost and a variable cost. This is because the material can be directly traced to each HVAC unit produced, and the total cost increases proportionally as more units are manufactured. Secondly, assembly labor is also a direct cost and a variable cost. The wages paid to technicians can be directly assigned to individual units, and additional labor hours are needed as production increases. Third, factory rent is considered an indirect cost and a fixed cost. It is a facility level overhead that cannot be traced to a specific HVAC unit, and the amount remains constant regardless of production output. Next, equipment maintenance is classified as an indirect mixed cost. It contains a fixed component, such as maintenance contract, and a variable component that depends on machine usage and repair requirements. Finally, electricity for testing labs is an indirect variable cost. Although it is an overhead expense, electricity consumption increases with the number of HVAC units being tested. In summary, variable costs such as steel casing and assembly labor increases with production volume, while fixed costs such as factory rent remains constant in the short term. Understanding these cost behaviors helps management plan production and control expenses more effectively. Next, I will explain the costing technique that is most suitable for the production of high-efficiency HVAC units. The recommended costing method is job order costing. This method is appropriate because HVAC systems designed for specialized environments, such as hospitals, are often customized according to specific client requirements. Unlike process costing, which averages cost across large quantities of identical products, job order costing tracks the cost of materials, labor, and overhead for each individual project or unit. This provides more accurate cost information and supports better pricing decisions. In addition, the order costing enables management to monitor costs at the individual job level, making it easier to identify cost overruns and maintain profitability. As shown in the example calculation, direct material, including steel casing and specialized component, amount to 1,000 ringgit. Direct labor consists of 24 hours of labor at 25 ringgit per hour, which results in a labor cost of 600 ringgit. Manufacturing overhead, which includes testing and maintenance costs, is 400 ringgit. Therefore, the total product cost is calculated as 1000 ringgit plus 600 plus 400 equals to 2000 ringgit. This means that the total manufacturing cost of one customized HVAC unit is 2000 ringgit. In conclusion, job order costing provides accurate cost tracking and pricing for customized HVAC units, making it the most suitable costing method for this project.
So hello everyone, my name is Lenzo Lerit. So today I will be presenting about 3.0, which is the budgeting and forecasting. So to evaluate the economic viability of Innotech's expansion, our team established baseline forecasting assumptions for our high-efficiency HVAC units. We are positioning these units at a selling price of RM 2,500 each, with the variable cost pinned at RM 1,600 per unit. Our operational fixed costs are expected to run at RM 200,000 monthly, totaling RM 600,000 for the first quarter. Starting at 200 units in month 1, climbing to 250 in month 2, and peaking at 330 units by month 3. This brings our total projected sales volume to 780 units. So let's break down how this sales figure translates directly into our operational budget for the first quarter. In month 1, a volume of 200 units generates RM 500,000 in revenue. After deducting variable costs of RM 320,000, we hit contribution margin of RM 180,000. Because our monthly fixed costs are RM 200,000, we actually absorb a minor initial net loss of RM 20,000 as we ramp up operations. By month 2, the tide turns. Revenue grows to RM 625,000, giving us a contribution margin of RM 225,000. Subtracting our fixed overhead, we break into profitability with a net income of RM 25,000. In month 3, shows the compounding power of scale. Revenue surges to RM 825,000, delivering a high contribution margin of RM 297,000 and yielding a strong monthly net income of RM 97,000. So cumulatively, for the entire first quarter, Innotech is projected to achieve RM 1.950 million in total revenue, generating a cumulative contribution margin of RM 702,000 and finishing the quarter with a strong positive projected net income of 102,000. So let's move on to 4.0, which is break-even and profit planning. To understand our safety boundaries, we calculated our contribution margin per unit, which is our selling price minus variable cost. This gives us RM 900 of margin per unit to contribute toward covering fixed costs. This equates to a contribution margin ratio of 36%. Using our baseline expansion framework, which accounts for a full operational structure totaling RM 450,000 in fixed costs, we can isolate our exact break-even point. So by dividing our 450,000 fixed costs by our 900 unit contribution margin gives us an exact break-even point of 500 units. In financial terms, dividing those fixed costs by our 36% CM ratio shows that Innotech must reach a state values of RM 1.25 million to completely cross the line into the black. So in conclusion, units at break-even point, the Innotech manufacturing needs to sell over 500 units of HVAC system to cover all its costs. The value at break-even point, these units equate to earning a sales value of RM 1.25 million and zones of profits and loss. At this stage, the total revenue equals the total cost, which result in no loss, no gain. Any unit sold above 500 result in a profit for the organization.
Hello, my name is Ibzur Rashid. Now moving on to the section 5, let us discuss our capital investment appraisal. Here we evaluate the financial viability of purchasing a new robotic welding equipment for our production line. To make a data-driven decision, we relied on a strict financial modeling. The numbers confirm this project is economically sound and meets all of our mandatory growth benchmarks. As you can see in the calculation breakdown, factoring in the initial cost and our expected savings, we achieve a positive net present value of 41,171. This means the equipment completely pays for itself and generates a clear economic surplus. Furthermore, our internal rate of return sits at a strong 15%, giving us an excellent buffer against any unexpected operational risk. Therefore, our official recommendation is to confidently proceed with the acquisition. Next, let us look at the section 6, focusing on inventory and cost control. A major part of our expansion strategy involves optimizing our physical assets to protect our profits margins. First, we establish a strict inventory classification. To maintain efficiency, we must ensure effective tracking of our raw materials, our work in process, our MRO, and our finished good. To control these categories, we are proposing three modern operational upgrades. First, we will implement a Kanban system, which is a demand-driven pull method designed to slash idle work in process and lower holding costs. Second, we will deploy digital tracking through RFID and a barcode to guarantee real-time visibility with zero manual entry errors. Finally, we will transition to cycle counting, running routine stocks audits to ensure high data integrity without ever suffering from costly factory shutdowns.
Hello, I'm Muhammad Arzani, and I'll be presenting about performance measurement and KPIs, and also 8.0 project cost management. So, for 7.0 performance measurement and KPIs, there are three engineering related KPIs. The first one is defect rate, second, machine downtime, and lastly, cost per unit. For defect rate, tracks the percentage of HVAC units failing quality checks, measures physical component flows, or integration errors during assembly. For machine downtime, calculations unscheduled stoppage of critical machines like robotic welders, crucial for optimizing asset operational capacity. And lastly, cost per unit. Cost per unit, where tracks overall manufacturing cost divided by produced units, includes steel casings, direct assembly labor, and overheads. Next, linking operations to financial ROI. Engineering metrics have a massive domino effect on financial health. Hence, eliminating flow errors and downtime is directly linked to higher margins. First, lower cost of goods sold. Reducing defects limits physical scrap waste, which lowers overall manufacturing COGS. Second, fixed cost allocation, where maximizing machine runtime optimizes fixed overhead absorption across unit. And last, higher ROI, where lowering unit cost below 2,500 will raise net profit margins. In return, it will boost return on capital investment. Next, 8.0 project cost management. Cost monitoring via earned value, which is EVM. First, integrating project baseline, where we apply earned value management, EVM, to track structural progress against our budget. For the efficiency metrics, we have formula evaluation indicates budget and timeline health. First, we have cost. The formula is CPI equals to EV over AC, where EV is earned value, value of physical work actually completed, and AC is actual cost in which incurred cost for work completed. And for schedule, we have the formula SPI equals to EV over PV, where PV is planned value in which authorized baseline budget schedule for completion. Next, cost tracking tools. We have two tracking tools. The first one is specialized project software, and the next one is ERP and ledger integration. For specialized project software, we deploy Microsoft Project or Primavera P6 to structure the expansions work breakdown structure. Inputs initial robotic welder installation budgets, also traces real-time timeline variance, and specialized project software also automate cost forecasting models. Meanwhile, ERP and ledger integrations, it consolidates actual cash outflows directly into our ERP costing module for maximum precision. where automatically process timesheets and material invoice, and also it imports actual welding machine expenses into EVM sheets, and lastly, it maintains visual comparative actual versus plain curves. That's all.
Next is the cost-benefit analysis for the copper tubing coil assembly. We compare two options, which is producing the component in-house or outsourcing it to an external supplier. So this analysis is based on 600 coil assemblies per quarter, and for in-house production, the total relevant cost is Rm 120,000 or 200 ringgits per unit. And this includes copper tubing and fittings, a direct labor, variable manufacturing overhead, and avoidable fixed overhead. And then for outsourcing, the supplier price is 185 per unit, and after adding incoming inspection and transportation costs, the total outsourcing cost becomes Rm 195 per unit or Rm 117,000 per quarter. Therefore, outsourcing gives a normal cost saving of Rm 3,000 per quarter compared to producing the coil assembly internally. Next, we use a decision tree and expected monetary value or EMV analysis to include possible risks in the decision. For the in-house option, there is an 80% probability of normal production with a cost of Rm 120,000 ringgit. However, there is also a 20% probability of equipment failure, which increased the cost to Rm 135,000 ringgit. And then the EMV for in-house production is calculated by multiplying each cost by its probability, and this gives an expected cost of Rm 123,000 per quarter. And next, for outsourcing, there is a 75% probability that the supplier delivers on time and meets the quality standard with a cost of Rm 117,000. However, there is a 25% probability of delays or quality defects, which increase the cost to Rm 138,000. So after considering this risk, the EMV for outsourcing is Rm 122,250 per quarter. Based on the cost benefit and EMV analysis, we recommend that Innotech outsource the copper tubing coil assembly. Under normal conditions, outsourcing saves Rm 3,000 per quarter, and after considering possible risks such as supplier delays or quality defects, outsourcing still has a slightly lower expected cost with an expected saving of Rm 750 per quarter. However, this decision should only be implemented if the supplier can consistently meet the required technical specifications, the quality standards, and delivery schedule. So, to reduce supply risk, Innotech should maintain a small safety stock of coil assemblies and identify a backup supplier. This will help prevent disruptions to final HVAC assembly, testing, and delivery. And finally, if production volume increases significantly in the future, the company should review this decision again because higher internal production volume may reduce the in-house cost per component. To conclude, Innotech's expansion can be financially beneficial if it is supported by proper cost control and operational planning. Firstly, correct cost classification and job order costing will help the company control the cost of customized hatchback units more accurately. Secondly, the break-even point is 500 units or Rm 1.25 million in sales. Since forecast sales are above this level, The expansion has the potential to generate profit. And then the robotic welding equipment is also financially acceptable. And Innotech should continue monitoring important KPIs such as defect rate, machine downtime, and cost per unit to improve efficiency, profitability, and return on investment. Finally, outsourcing the copper tubing coil assembly is slightly cheaper, but supplier quality and delivery must be controlled. So overall, we recommend that Innotech proceeds with the expansion while maintaining strong costs, inventory, and supplier management. That is all from us. Thank you.